This video will cover the review for test number 2. So the beginning of chapter 2 was on all of these things about intercepts and decreasing and increasing intervals and max min. So that's what the first 12 problems on the review referred to. So is this the graph of a function? The answer is yes, because it passes the vertical line test. Any vertical line you draw will only touch the graph once or less. X-intercept refers to where it crosses the x-axis. It crosses the x-axis in 3 places, and we'll name those with just their x values. So this is -4, comma, this one is 1, 2, 3, 4, 5, and this one is out here at 7. You do not have to write them as the ordered pairs. The y-intercept is where it crosses the y-axis, and it crosses up here at 1, 2, 3, 4, 5. Same thing, you don't have to write it as an ordered pair. Determine the value of f of 3. Remember what that function is. That's f of x. That means the x value is 3. So let's find the x value of 3, 1, 2, 3, and go and meet the curve. Well, it goes up to meet the curve. So that's the point right there that has an x value of 3. All we have to do is determine the y value, which is up 1, 2, 3, 4. So f of 3 is 4. Increasing interval refers to the graph going up. Increasing is like the roller coaster. It's going up. All of that. It's also going up here. Now remember, when you're naming increasing and decreasing intervals, you need to name them in terms of x values. So the x value right here is 1, 2, 3, 4, 5, 6, 7. This is -7. And the x value right here is 2. We're not concerned with the y values. When you name the increasing or decreasing intervals, you name them as intervals of x. Also, you name them as open intervals. So -7 to 2. And the other one started here and stopped increasing there. And this is over 1, 2, 3, 4, 5, 6. And this is 7, comma, 6, 7. Decreasing interval is going the other direction. All of this is where it is decreasing. Same deal, we need to answer in terms of x. So the x value right here we already determined was 2, and the x value here is 6. So this is the open interval, 2, 6. Determine the x value where f of x equals 6. That means we're looking for the x value. We know the y value, so we go up on the y-axis, 1, 2, 3, 4, 5, 6, and we go and meet the curve, which happens to be over here, and that x value is 2. Same picture, some more questions. What is the domain? Remember, domain refers to left to right. So this thing begins here and ends here. So that x value is -1, 2, 3, 4, 5, 6, 7. And that x value is 1, 2, 3, 4, 5, 6, +7. It is with brackets because those are colored in circles. So this is from -7 to 7 is our domain. The range is bottom to top. So what's the lowest y value is right here. The highest y value is there. So that y value there is -1, 2, 3, because that was the point, -7, -3. That y value there is up 1, 2, 3, 4, 5, 6. So that is from -3 in brackets to 6. Relative max and min. Obviously, you can tell a maximum occurs right here. And the x value right there is 2. The y value right there is 6. But you have to answer this question correctly. At which refers to the x value. What is refers to the y value. So once you have identified your ordered pair, it occurs at 2, and the relative maximum is 6. At which point do we have a relative minimum? You can see right here, this is the minimum. Don't look over here. You cannot have a max or min at an endpoint, so forget that point. Like relative max, once you identify that the minimum is this low point right here, then you just have to look at the ordered pairs. This is 1, 2, 3, 4, 5, 6, -2. That's that ordered pair. So at which, the number at which a relative minimum occurs is the 6. What is the relative minimum? -2. The last question asks, is the graph even, odd, or neither? You can look at the graph and tell it is not symmetrical to the y-axis, therefore it's not even. It is not symmetrical to the origin, therefore it is not odd, which means it must be neither. Next couple ones ask to give the domain and the range of the function. Perhaps the easiest thing to do is for you to type this in your calculator and see that the parabola looks something like this. This is just a rough sketch of it. You can tell the domain of any parabola, is the infinities, from negative infinity to infinity. The range of the parabola is talking bottom to top. So if that's my vertex right there, that happens to be the point 2,1. So the range, this is domain, and this is the range. The range is going to go from 1, which is the y value, all the way up to infinity. With the curve, 1 gets the bracket, and the infinity gets the curve. Same thing, you can type this in your calculator and see that this is the absolute value. So this is a v, and it's something like this. The domain of absolute value also happens to be the infinities. And the range, like the parabola, we're talking bottom to top. So the least y value is 3, and it's going off to infinity. Determine whether even, odd, or neither. There is the process of f of x, f of negative x, negative f of x that you can look at. But remember what I taught you in class, and this will work on all of these. Just look at the powers. If all of the powers are odd, it is an odd function. Of course, you can also type that in your calculator and look at it, and it is symmetrical to the origin. This, be careful here, this you have to think about as 7x to the 0th. So is this even or odd? It is even because both of those powers are even. 0 is an even number. You can type it in your calculator and look at the picture if you want. Here, x cubed plus x1 x to the 0th, you have an odd power, you have an even power, so this is neither. These powers are both even, therefore this is even. So that's just a shortcut that will work on all of these. That'll save you having to do the f of negative x and the negative f of x. All right, graph the function and name the domain and the range. This is a piecewise function. The piecewise function requires a bit of work here. We have two different functions. That's why I have drawn two different t-charts here. So this is the 2x plus 1, and this is the chart for x squared minus 3. When you graph using a t-chart, you of course get to pick whatever numbers you want, but this tells me I need to pick the numbers that are greater than 0. I do put 0 in the chart, and I put a little star on it, and then greater than 0 is 1, and then 2, and that's probably enough to get my chart filled out. The reason I put a star on 0, this just says x greater than 0, so that tells me at that point I will do an open circle when I graph this. Do your arithmetic, or type it in the calculator if you want. The arithmetic on this will be 1, this will be 3, and this will be 5, either by you plugging the numbers in and doing it by hand or looking at your chart from the calculator. Over 0 up 1, but give it an open circle. Over 1 up 3, over 2 up 5, and then we're going to graph a line right here if I can get this to work. And it's going to look something like that. Let's talk a second. The reason this has an open circle is that x is not equal to 0, but the very next number, which is greater than 0, is, and that's why we do the open circle, kind of like you used to do when you graphed your inequalities. When you do this, you need to make your t-chart a little bit larger, because x squared minus 3 you should recognize is a parabola. And if it's a parabola, you need more points. Of course, you can look at the t-chart in your calculator by using the table function. The numbers I need to use here are 0, -1, -2, -3, and that may be enough for me to see what's happening with the parabola. When you do your arithmetic on this, plug 0 in, you get -3. Plug -1 in, you do -2. -2 gives you 1, -3 gives you 6. And if you don't want to do this arithmetic by hand, you can use the table function on your calculator. Type that in, look at the table for these numbers, and those numbers pop up for you. So now I need to graph this. Over 0, down 3. It does get a colored in circle, and the reason it does is because it says x less than or equal to 0. -1, -2, -2, 1, -3, up to 6. And I know it's a parabola, and I'm going to have a real hard time drawing this here, but it looks something like that. That is your piecewise function. Now, domain refers to your x values. How does this graph extend from left to right? Well, this is taking off forever and ever and ever this way, which means it is from -infinity. And where's it going over here? It is also going to infinity. Range refers to bottom to top. The least y value here is -3 with a square bracket. And where's it going? It's going on up to infinity. These next two are asking you to graph. You should recognize that these are lines, which means if you can name the slope and the y-intercept, you can make a decent graph of this. The y-intercept is this point right here, which is -3. The slope is the number in front of x, which is 1/2. You might remember that what that is talking about is rise over the run, which means it is going to go up 1 and to the right 2. So y-intercept of -3, it is a y-intercept. That's why the first dot goes on the y-axis. And then count your slope. Up 1 to the right 2. And connect the dots, and there's your line. Of course, you can type that into your graphing calculator and check to see if you've got it graphed correctly. Now, the reason I graphed number 21 first is that this was already in slope-intercept form. This one is not, so we'll have to do the work to get the y alone. Subtract 3x from both sides will give you -3x plus 8. Divide everything by 4 and simplify gives us y equals -3/4 x plus 2. And now I can name my slope and my y-intercept. The y-intercept is 2. You could name it with the ordered pair 0, 2 if that's helpful to you. The slope is -3/4. Remember, I always let the negative go with the top. When you think about counting this off now, because that is -3, you will go down 3, but because that's a +4, you will go to the right 4. So first dot on the y-axis at 2. And just graph or count down 1, 2, 3, count to the right 1, 2, 3, 4, and connect the dots. I don't do so well with this tool, but there you go. There's your line.